Patricia.
Hello. Thank you so much for your talk. It's really exciting. So if you go back to one of your slides where you were showing how your model was interfacing with the physical world, I was hoping you can talk a little bit more about the process. How is the physical interface working out? Do you have microprocessors in the middle to do the interface? Yeah, so all those type of controlling part.
Yeah. So right now, the AI portion of this that we're doing is on the picking out the next alloys we want from our model and studying the results of it through that's sort of like a machine learning task of when these images are ripped apart that feeds back in to the model. We are not yet controlling this with like Ursa agentically, but that is certainly on the really soon on the table. But so for right now, this microcontroller picks up results from the foundation model that says which alloys to mix together or which metal bits to mix together. Yeah.
There's a follow-up question. You mentioned during the talk. Thank you. You mentioned during the talk that it's like 30 minutes, I think.
Yeah.
The whole process. Why 30 minutes? Where the time is going?
Believe it or not, most of that time is spent in pulling the vacuum and solidifying the thing into a dog bone shape that we can pull apart. So the arc melter, this guy here, I wonder if this is a movie. It's a movie, sweet. This guy right here actually picks up the components and melts them, so it ends up like molten, right, as it's stirring it together. And then we have to turn that into a structure that is solid enough to rip apart. And the way that's done is by putting it into like a crucible and then pulling vacuum on it. That vacuum takes about 20 minutes to do right now. Yeah.
Sorry, Anna.
So one comment and one question.
Sure.
First, I highly recommend the Ursa. I found about it in January and I played with it and it's really cool. Second, you were talking about building the foundation model. You said you don't need a lot of data. You can just take some data from the internet and then specialize it on. Do you keep track of what data you use from the internet to train and?
Yeah, we have a whole effort that's got like tables of trained on this data or pre-trained on this and fine-tuned on this. What if we pre-train on these both and fine-tune on this? What the underlying physics were from these areas and whether or not we can pick that up downstream. So we have yes.
That's excellent.
We spend a lot of effort on that.
Yeah, I think that's excellent. Do you plan to make it available?
Yeah, I don't see why we wouldn't. I don't see why we wouldn't. I don't think that we've put that up on. It's on an internal GitHub page right now, but I don't see why we wouldn't do that. Yeah. The intention of all of this is to make it all open source, and we've done that in many. And I don't say that just like someone says. Most of this already is available. I didn't do a good job of putting the actual links for it, but feel free to write me, and I can, if there's little individual topics you wanted to dig into, I can put you in touch with the people. So,
I have a question.
Yeah, please.
Pure manager guy who tries to understand agents a little bit more. So you mentioned fantastic things about Claude and Claude Code, and why don't you just leave it to do that? But on the other hand, you say that you have a deep deal with OpenAI, which is working directly within you, and then raise a lot of questions about security.
Sure.
So how do you take that decision? Are you using both of them on purpose, or why one is better than other? These are, as I say, let's call it procurement questions,
sure,
not strategic ones.
The answer to that's actually very pragmatic. The reason is, so I told you, we have the private installation of OpenAI on our private classified network. So that's only for certain topics. So you wouldn't have seen any of the results from that today. Why would I use Claude in the other spaces? The other thing is that Our other OpenAI usage on the open side is only for fully open data and fully open space. And so there's this gulf. Our lab has sort of fully academic open communications. Then we have what we call CUI, which is sort of like official use only type information. And then we have the classified information. You can think of it as those three groups. That middle group, we do not have the ability to use OpenAI for right now. And so right now, that middle group, we're routing through Claude. We do have the ability to use what's called AWS Bedrock for that. It's approved for that level. And they do not have OpenAI on that system. They have, we can run 120B on that system.
Yeah, because, opens the immediate question, what do you mean that you don't have the ability? It's a technical strategy. Because, again, procurement-wise, why don't I put all my eggs in the same basket? Why do I put one provider that gives me this and that? Or strategically, let's try to spread the risk.
Of course, we're interested in strategically evaluating these. That's really not the right answer. The true answer is that we have approvals, that are not entirely within our control, that are controlled by site offices and at the federal level of which systems are approved and which ones are approved for these different things.
Yep. Thank you.
Yeah.
Do I see any other hand? Jason, perhaps? For Jason, the microphone, please, Dave.
So are you still, if you're trying to run something like Ursa, that's still requiring a rack full of GPUs or something?
Oddly, no. So I run it almost always on my laptop. Because what are you exercising? You're exercising LLMs. Now, where are those LLMs? If those LLMs are local LLMs, sure, you need GPUs. If those LLMs are local to your data center, because there's private data, then of course you need to host those somewhere. In our case, we're using those on AWS Bedrock, so we're routing that through a private network, or we're routing it through our classified cluster, or we're routing it through the open web to OpenAI, like on Azure. So in none of those cases am I running those GPUs. Okay. So when we do connect in with like the foundation models, like for instance, I was showing, here, these foundation models, what we call science foundation models, SciFMs, these science foundation models are trained on tons of GPUs. And then when they're run in inference mode or in prediction mode, they usually require very less GPUs to run in inference mode. Sometimes we can run those on a laptop, maybe a M3 or so. But most of the time we host those on servers at the lab that are basically MCP endpoints that have GPUs on them. But they're serving up these science foundation models that you hit with inputs that return images like this. Now, I kind of washed away this and made it look like it returns one image. Our problems are really lots of channels. And so there are things like, this looks good on a slide like this, but really it's things like density, pressure, velocity, temperature in the X, Y, and Z. All those are different channels. And so these things end up being, usually we run about 38 to 40 or 46 or so dimension data sets. So maybe you can imagine them as 2D by 30-some dimensions. And the transformers are axial attention transformers when we use the morph stuff. And they're looking across those dimensions and across time or time steps. That's a little bit more than you asked, but it needs the GPUs for those purposes. I've been running Ursa this week on this MacBook Air they gave me to come here with. So yeah, it's absolutely easy to play with, and you can absolutely play with it with like 20B or I think it's the open source stuff. You'll get okay results. You can at least test it out, and. I would say look at the examples directory. There's a lot of really wild examples that sort of explore different ideas, just to give you a taste of what it can do.
We all have an idea that Los Alamos is directly linked to Manhattan Project, and the Oppenheimer movie only consolidated that. But you mentioned Manhattan 2.0, and that leads into the Genesis mission, which, if someone has been following what's happening, apparently is the big, regaining the U.S. leadership in everything which has to do with innovation industry or what so. Can you give us a high-level view? We read in the news that, okay, there is a meeting happening in Washington, D.C. this week, but is there a broader strategy in, how can I say, in innovation or a way of thinking that we should be paying attention, or is just a geopolitical? And I'm not trying to push the boundaries on the question.
Well, so I'm, if you will, just a performer in Genesis mission. So I'm not a visionary in making the decisions. I will say the other co-lead, the main PI of Artemis, is at the Genesis mission model's lead. And so one of the things that why I'm probably here instead of him is because he's so focused on Genesis mission and helping to get that off the ground right now. And so Emily and I both work for him on Artemis. Genesis has started. It's worth noting that like at LANL, I mentioned this project, Artemis, you've been hearing about, is $20 million a year. Genesis at LANL is only $6 million a year. So we kind of laugh about this is intended to be a much, much bigger project than Artemis. But right now, we have way more effort going on inside of Artemis. The intention is to ramp down and bring the other one up, but that funding needs to come online. Now, as far as the planning of it, it's not fully clear to me where everything's going, but I know there's a massive emphasis in public-private partnerships. What I'm seeing mostly right now is technical demos to demonstrate capabilities, particularly cross-laboratory capabilities, really exercising things like these MCP services. MCP isn't secure, so we've been adding technology and to make MCP secure. Things like, how would I sit on a LANL supercomputer but run models that are served up in AWS but connecting to supercomputers at Argonne and data, perhaps at Pacific Northwest National Lab, that kind of cross-lab. That might sound weird to you, but if you haven't worked in this space, the DOE does not have a good ability to exchange authentication tokens across laboratories. So we're doing a lot of work doing that right now. Stuff that you probably could argue we should have done years ago, but it's never really been the focus of the Department of Energy to have sort of such cross-laboratory emphasis. And so a lot of the work right now is basically making those pipelines work and demonstrating that they work.
You're tempted to ask Blair if we have that here. Okay. Yeah. So do we have any other question from the floor? If not, please join me thanking Nathan for this extremely exciting presentation.